right, hello and welcome to lesson 3C, using substitution and logic. So today we're going to be solving systems using what's known as substitution, because graphing is not always going to work. So let's see this very first example that says solve the system by graphing. So you guys did this already in the last couple of lessons and you were pretty good at it. And so let's go ahead and graph this first one. We see its slope-intercept form, so we can see it starts at -1, and then it's going to change by adding 3 to the y for every one x. So up 3 over 1, up 1, 2, 3 over 1, up 1, 2, 3 over 1. Or the opposite of that, down 1, 2, 3, left 1, down 1, 2, 3, left 1. So now I've got a whole bunch of points that I can line up so I can make that first line. All right, so nothing new yet. This is just what we did last week, but we're trying to solve by graphing. What about the second one? So the second one starts at 3, so I'll put my point at +3 on the y, 0, 3, and then it goes down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Now I can already see this line is going to cross, and so I'm going to go ahead and draw that line in there. Let's make sure that it's lined up really, really well. There we go. Let's get that in there. All right, so there's my second line. Now remember what the answer is to a system. The answer is the cross point, and so we're looking for the x and y of a cross point. Now in this case, we can see they're crossing, but they are not crossing at a very nice spot. It looks like it might be a little less than 1, so maybe 3/4, and a little more than 1 on the y, so maybe 1 3/4, so or 1 1/4 maybe. But we can't tell for sure on this graph. And so underneath this, I want you to write down, not all graphs are perfect. So another way to answer is to use algebra. So we can use what we know about these equations to set up when they're going to equal each other, because that's what this point really means, right? This point where they cross is that one and only place where they're the same, where they're equal, in other words, right? Where the x and y are equal on both equations. So sometimes on the graph you can't tell, and so we need another method. We can't always solve by graphing, even though you're good at it. We can't always use that method. It's not always precise. So when we're thinking of another method to use using algebra, we already talked about this in class, but I just want you to write it down. So this is what we had already discussed. So if $ is equal to exclamation point and exclamation point is equal to smiley face, does $ equals smiley face? So think, is that true? If this equals that and that equals this, are these two things equal? Remember what we discussed, and yes, they do come out equal. Why is that? So since the $ and the happy face both equal that exclamation point, we can exchange or substitute one symbol for the other. In other words, since this is equal to that, then I can replace it with the $ and write it as $ is equal to smiley face. So what does that mean to our equations? What does that mean to all of this? Well, that means if I see things that are equal, we can replace them. We can exchange, we can substitute. Let's look at that with an actual equation here. So for this one, we see y is equal to x and we see x is equal to 5. So is there something that I could exchange out? Think about it, think about it, think about it, and yeah, I see something that's equal here. So I have an x here and I have an x here. And so what that means is I can replace the x with what it's equal to, which is a y. And so I'm going to replace that with y equals 5. All right, well, don't I already have my answer now? Remember, what we're looking for is an x and a y that makes this set of equations true. I already see x is 5. I just had to figure out that y is also equal to 5 because the x and y are equal. So that's one way to see it, is to replace what we know from the original equation into that one. Otherwise, we can replace this way. If y is equal to x and x is equal to 5, that means y is equal to 5. Okay, what I would like you to do is try that on your own for this one. Pause the video, try it. Okay, hopefully that was enough time. Hopefully you paused it and you tried it on your own. Let's see what you got. So this already says x equals 2, so I know part of my ordered pair is that the x is 2. We just have to figure out the y. Because I know x is equal to 2, I'm going to put a box around the 2 this time, and I'm going to point it to where I see the x. And that's where we plug it in. So that means I could write y equals 2 plus 3, and 2 plus 3 is 5. So we get y equals 5. So our ordered pair that would work for both of these is 2, 5. All right, so that's nice and easy when they already tell us what the variable is equal to. How about when they don't? So let's look at this one, y equals x plus 1. Remember, we still want an ordered pair. We still want to find x and y so that we can see the one point where they're crossing. So looking at this one, y is equal to x plus 1, and 7 is equal to x plus 1. So I see a couple different ways to look at this. If we see both of these are equal to x plus 1, then y must be 7. That's the way I see it. Another way to figure this out is 7 is equal to x plus 1. I could figure out that x, couldn't I, by subtracting 1 from both sides? Okay, so then we would have 6 is equal to x. So 6 is equal to x. And if I plug in 6 right here, I would get y equals 6 plus 1, which means y is 7, like I thought. So a few different ways you could do this. I like to see y is equal to x plus 1, 7 is equal to x plus 1. I look for what I can exchange out. These are the same, and so I can exchange those out, and I know y would be equal to 7. All right, let's look at this one. Again, we're looking for an ordered pair. This time, we see y is equal to 2x, and x plus y is equal to 1. So is there something I could exchange out of here? Well, I do see a y by itself right here. Y, they're telling me, is equal to 2x. So if y is the same thing as 2x, then I could replace that y for a 2x. So that means I could write this as x plus 2x equals 1. All right, well, that's simple enough. X plus 2x, that's 3x equals 1. If I'm trying to get the x by itself, I would divide both sides by 3, right? And so that gives me y is equal to 1/3. All right, fractions are numbers too, and that's really what we would expect. Remember, we're using this method really for these questions that have fractional or decimal coordinates. So I would actually expect fractions here. So I see my x is 1/3, but I still need to find y. How could I find y? Well, there's a couple different ways. I could either plug in right here that x is 1/3, or I could plug in up here that x is 1/3. To me, this one's a little bit easier, and so I'm going to plug it in right there. I see y is equal to 2 times x. I now know x is 1/3, and so that means I would get 2 times 1/3, which is 2/3. Okay, so that would be the point where they're crossing. 1/3, 2/3. I don't know if you can read that, but that does say 2/3. Okay, so again, for substitution, we're going to look for a variable that's by itself and replace that variable with what we see. All right, let's try that on the back. There's just a couple more examples today. We'll be trying this method all week, so you'll get pretty comfortable with it. Let's look at this one. X equals 4y plus 1, and negative y plus x equals 8. Do I see something I could substitute out? Well, I see x is equal to this expression, which means I could replace this x with that expression, right? Because they're equal. I see x is equal to that, so I could replace it. I could exchange that out. And so I'm going to rewrite this, negative y plus, and instead of x, I'm going to write what x is equal to, 4y plus 1. And I know that those together will equal 8 because of this equation right there. Now we just combine like terms and solve. So negative 1y plus 4y, that's going to give me 3y. Plus 1 equals 8, and now we subtract the 1. Oops, I wrote 7. Now we subtract the 1, and we get 3y equals 7. Divide both sides by 3, just following our steps of solving equations, and we get y equals 7/3. All right, so that's the y. Remember, I'm looking for an x and a y. So for y, I have 7/3. Now, how would I figure out the x? Well, I could plug in what I know y is for either of these equations. Which one do you think might be easier? We could plug in for y right here, multiply by 4, and then add 1. Or we could plug in y right here and add the 7/3 to both sides. Really, it doesn't make a difference. I'll go ahead and plug in up here because that might be less work. So x equals 4 times what we found for y, which is 7/3, plus 1. Okay, 4 times 7/3. Well, let's see. 4 times 7 is 28 over 3. Plus, well, I really want this to be common denominators with the other, so I'm going to change 1 into something over 3. So times 3 times 3. So that's going to be 3 over 3, right? So we have 28/3 plus 3/3. 28/3 plus 3/3, that's going to be 31/3. And I'm actually going to leave it like that. If we were plotting this on a graph, we might want to change it to a mixed number, but keeping it improper is just fine. Okay, that would be our answer. Let's go ahead and try the next one. I see x equals something. X is equal to y plus 2, and y plus 2 is equal to 7. Well, don't these match? Y plus 2 and y plus 2? Oh, we found a match. We can exchange those out and just write that as x equals 7. Well, that's an easy one. X is 7. So if x is 7, how would I figure out y? Well, I can plug it into the one that has an x. That means 7 would equal y plus 2. Subtract the 2 from both sides. We'd get 5 is equal to y. Okay, that was easy. Now, how would we check to make sure we're right? Well, we could plug it into both, but we can already see that that would be correct. All right, let's try this one. Y equals 5 and x plus y equals 9. All right, well, if y is equal to 5 and I have a y right here, that means I can plug that in. So that means we'd have x plus 5 is equal to 9. And then we'd just subtract 5 from both sides. So x is equal to 4. All right, so we have our answer already because we have an x, which is 4, and a y of 5. We have our x and our y, so that works out. Now, does x plus y equal 9? Does 4 plus 5 equal 9? Yeah, that works out. All right, just a couple more examples. Let's try this one. X is equal to 2y, and 3y plus x is equal to 2. So I see x by itself. X is equal to 2y, so that means I can plug in 2y for x. Okay, so that would give me 3y plus 2y equals 2. 3y plus 2y, all right, well that would be 5y would equal 2. Divide both sides by 5, and we get y equals 2/5. Okay, so we have part of our point. We have the y part. We have y is 2/5. Okay, but now how do we find the x? Well, we could plug it in. We could either plug it in right here or plug it in right here. This one looks easier to me, so I'm going to plug it into the top equation. So x equals 2 times y, and we now know y is 2/5. Well, 2 times 2/5, that's going to give us 4/5. So x is equal to 4/5. And that's our answer. One more. This time, y is equal to 3x minus 4, and y minus x is equal to 6. So I see a y by itself right here, and it is equal to this whole expression. I see another y down here, and so that's where I'm going to plug it in. So now instead of y minus x equals 6, I'm going to plug in 3x minus 4 for the y, then copy the rest of the equation. Minus x equals 6. Now it's just a matter of combining like terms, so we have 3x minus x is going to be 2x minus 4 equals 6. Now it's just draw the line, circle the variable. Instead of subtracting 4, we're going to add 4 to both sides. That gives us 2x equals 10, and x then would equal 5. So now we know our x, we just need to find the y. All right, so I'm going to plug it in. It looks to me like this top equation is a little bit easier, so I'm going to plug it into the top one. So y would equal 3 times, instead of x, I'm going to write what I got, 5 minus 4. So that means y equals 15 minus 4, which finally means y would equal 11. All right, so there's our answer. This is what it looks like when we solve algebraically. Now, whenever I get a whole number, that tells me we really could have graphed it, but you need to be able to find this stuff without the use of a graph because they're not always going to get one, or they're not always going to work out to nice, happy whole numbers. This is a difficult method, so try your best, do the exit ticket, and as always, let me know if you need help. Yay, math!